All right. Welcome everybody to today's info session from the Africa Deep Tech community. And we're really thrilled to see you today, joining us from wherever you are in the region and indeed the world. My name is Chukwemeka Afibo, and happy to welcome you to our session today. And um, today we're going to be talking about deep tech opportunities in power management and computing. But before we go into that, I'm going to just give a short recap about the Africa Deep Tech Challenge. What it's about, why we're doing it, and what you're gonna get out of it if you participate. And then after that, we will then go into the main presentation for today. So the Africa Deep Tech Challenge 2025 is basically an innovation challenge that is asking participants to build awesome solutions in the area of resource-constrained computing. We're doing this because we believe that this is a very important area for the region to focus on, and we want to encourage as many people to either build solutions or showcase solutions that they have built in this area. As you already know, there's a lot of, there's a lot for everyone in terms of prizes and giveaways and knowledge sharing sessions like this one that hopefully will make you a better innovator regardless of your field or area of deep tech you specialize in, and encourage you to keep going, right? That's really why we're doing this. We want to see awesome, crazy, first principles based innovations in the area of resource constrained computing. And I'm going to put a link in the chat for you where you can find more information about the challenge in case this is the first time you're hearing about it. So I put the link in the chat there. All right. So if you've been following the challenge, or if you've registered, if you're a participant already, you will probably know that we have four prize categories. So the first prize is an equity-free grant of $8,000, right? And we've got prizes all the way down from 8,000 to I believe $4,000 or so for the third prize, to $3,000 for the third prize. But one of the more interesting prizes is the one for the solutions in power management that is sponsored by IHS Towers, right? And that prize basically is saying that if, regardless of what you build or your position in the challenge, if you are voted to be the best solution in the area of power management and computing, right, you're going to get a grant of $4,000, regardless of whether you're the best overall in the competition or not. If you are the best, if you're voted to have the best solution in power management, then you're going to get a grant of $4,000. And it is, for this reason that we thought it would be great to have a dedicated session on that subject area today. And that's what we're here doing today. And the way it's going to work is that we're going to go through the session, and after the session, we'll take questions, we'll do the Q&A, and feel free in the meantime, the chat is open. Put your comments in the chat, put anything you would like, be interactive in the chat. And if you have specific questions for the speakers, use the Q&A section so that we can spot the question and address it either during the session or after the session. But once the presentation is done, feel free to ask your questions and we'll be here to address them. Great. So having said that, it gives me great pleasure to introduce our guest speaker for today in the person of Shehu Umar. He is a technology executive. His career spans business development, growth management. He's done sales, basically every aspect of uh of tech when it comes to the power management and infrastructure sector. Shehu has been there and done that. He is currently the director of Trapezion Africa Limited. His career spans working for the likes of IHS Towers. IHS Towers is one of our major supporters for this challenge. And if you don't know them, they, I'm sure Shehu can talk more about them, but like if you've ever seen a cell phone tower in Nigeria and indeed many parts of Africa where they have infrastructure, there is a huge chance that that cell phone tower is powered by IHS, right? And so you bet that Shehu knows what he's talking about when it comes to power management and computing and what the deep tech opportunities are on there. And so without wasting any more time, please welcome Shehu Umar to take it away from here.
So thank you very much, and good afternoon and good day or morning to others that are in earlier time zones. I believe we're probably way ahead. So as thanks, Chukwuemeka, for the intro. I appreciate it. And just to recap from an intro perspective, yeah, I graduated school as an electrical engineer with electronics, telecommunications major, and I spent that's 25 plus years ago, and I've spent the last 20 years working in infrastructure sector. Early stage is quality control, product line management with a US-based company called Harris. We're building microwave and teleco infrastructure to build backbones across the country connecting cities. Much later, I did technology, a bit of software, building platforms, creating marketplaces, and then on to more of power, where I have been doing a bit of control systems, worked in a few hydropower plants, still do a bit of consulting there. And also more recently, my role in IHS, helping to do corporate venture innovation, looking at how you build ideas from within companies and how those ideas can scale, how you birth new companies, and basically what Apple and Amazon does, how do you do it with the African context, right? So as he indicated, IHS, where I worked, is part of the sponsors of this program. And for me, I worked there to basically, they were an infrastructure company. They have 16,000 towers across Africa. MTN, Airtel, and all the companies basically are supported by IHS. So just to kind of quick dive into the presentation. The focus is, I have a few slides to present, deep tech opportunities in power management and computing. The idea is to basically give an overview of grid. So we will look at some architecture of how grid works, the very open side of grid management, right? So there are parts of grid management that are more closed and very mission critical. And when I say that, I mean things like SCADA and how you connect to generation plants. That will not be the focus here. The focus will be on the side that is more demand side, and the side that we are very aware of, the metering side. And then I go on to what a typical power monitoring or power management solution looks like in a traditional tower as we have it currently, right? So I will quickly go on to the next slide. Sorry. Okay. So yeah, so this slide I will be speaking about grid power management architecture. this is the first of the slides I will speak to. And please, if you have questions, please take note. After this, I will probably go on to 2 more slides and I will quickly try to wrap up. Now, for startups and companies that are looking for opportunities in the power sector, there is a massive opportunity for what we call mission critical communication for metering assets, right? So across Africa, there's the transformation of utilities from what we consider the traditional model of a utility to a standard model. So the standard model of a utility and managing grid networks is basically real-time energy sales, which is what happens in the US, what happens a bit in Europe. But in Africa, a lot of our grids are still run by governments. The governments are what we call the traditional model, a vertically integrated. The government owns the generator, they own the transmission company, they own the distribution company. What is happening now is it is transforming, it is changing. If we look at Uganda, we look at a couple of countries, even Ghana, and then more recently, ESCOM in South Africa, they are selling off parts of these value chains, right? Nigeria in particular is the most disruptive. A little bit of here and there, more chaotic, but a bit more disruptive. Nigeria has transitioned much further than most African countries from the traditional model with the sale of discos to majority private ownership. The transmission company split in two. You have an independent system operator and you have the transmission company still run by government. And then you have generation companies, about 28 plus, that are majorly private owned. I think out of that 28, maybe 10 are with government, but ready to be sold, right? So, but when we look at performance, it's not shown in terms of performance, but we look at other countries, maybe Umeme in Uganda, the government concessioned the distribution company for 25 years, and it's been a perfect model for utility outsourcing because their performance is very, very good. And this is standard and has been researched by so many companies, right? So that said, the essence of this is to kind of throw light into what startups can do in this space. Deployment of metering in a lot of African countries is transitioning to smart meters. What I think and I believe is there's an opportunity to basically build infrastructure from the interface of a metering asset, which is what we call the network interface card. Every meter has an interface. That interface is basically a network interface card. It interfaces to a communication network. From that point to a meter data management system that is usually run by a utility, there is an opportunity to build a product. That product is a mix of communication, an IoT platform, managing connectivity and delivering what I consider mission critical, reliable connectivity, where uptime is 99.9, right? Now, that uptime is typically delivered by what I consider a specific purpose network. So a mobile network is what we consider a general purpose network. So it runs everything. It runs, you have fiber, you have SIM card, you have all sorts of things. You dump it on a mobile network. It's like a public network. It moves on. What you need to create to guarantee reliability is a private network, either within a mobile network or you build one yourself. So when we look at DSTV that provides us cable, that's more of a private network, right? It delivers just one service and it tries to do it reliably, right? So the essence of this is to say, in the context of grid power management, there is an opportunity to build that type of network. What I try to outline here is a couple of them. You have LoRa, you have RPMA, random phase multiple access, you have 4G LTE, traditional, And then there is a new variant, which we call 4G Cat1 base, right? It is an evolution of 4G that is primarily focused on IoT, right? And does not need a network upgrade. It's very recent and it's still being adopted, right? Uh, Outside of this, you also need a platform that manages these networks, right? So when you deliver a network to guarantee reliability, you need to connect it to an engine that gives you visibility. This way, you are able to say, okay, when the asset is down, let's say the meter is not functioning, you can query the NIC card and get the status of the communication, and it will also give you, oh, I'm communicating with the meter, but the meter is down. Maybe there's no power or the meter has been damaged, right? So this kind of business, and then back to the analytics, these companies are looking at enterprise grade meter data management systems. These data management systems require massive data centers. Not massive, but to some extent, when you are looking at 1 million meters reporting data every 15 minutes, you want to be able to aggregate that data, keep it somewhere at relatively cheap cost, and also use that to do analytics. Now, because these utilities also deliver power, they do not see cloud as the best option, right? They want to say, oh, after all, compute power is what I sell. I sell power that drives compute. Why can't I sell my power to the data center? So I would prefer that I have an on-premise or a hybrid data center so that I can sell my power, that basically the power that they are selling is the one helping them mine data, right? So this is the context of where I see opportunity for power management within the grid. There is SCADA, where you look at energy flows along the national grid from generation, but I think that area is still a bit very closed because of the fact that it is kind of maybe I would say at this point very regulated. But this area within a lot of utilities where you have different meter manufacturers, there's an opportunity to look at what you can, how a startup can play in this space. You deploy an agnostic network, deploy technology that is basically mission critical, is very reliable, different meters from different Chinese manufacturers, but you try to look at what are the standards, IEC standards. How do I aggregate data from these meters and move them across this flow? So to wrap up, I think for the grid power management architecture, this is what I feel this is a good opportunity for startups to play. Within the average utility, there's 10, 20, 30 different models of meters. This creates challenges. What they do is each meter manufacturer sells a software platform to basically manage its own meters. So there is a lot of vendor locking ongoing. That startup that helps to unlock everything and make it open and collect data irrespective of meter and move it around. I think there's a massive opportunity there. And then when you have this kind of architecture, you are now able to build other types of applications. Is it demand response? I want to shut down the meter in my house. I want to load my meter automatically. I want to see how I'm trending in terms of electricity when I'm not at home versus when I'm at home. All of these things are the future of what we call the smart grid. So, so for the purpose of the power management architecture, I would say this is a massive opportunity. I'm open to questions in this area. I understand it reasonably well. So if anybody has questions, please, after this session, I'll be happy to answer. So the second framework I would like to talk about is the Tower Co-Power Management framework. Apologies for the repeated numbers. The architecture here a bit not so clear to people that probably are not operating in the telco space, but I would like to speak to how a site operates. And this is the traditional site. It's going to evolve, but I think the focus is on how do you aggregate data on a traditional site. Credit for this goes to a company called Circadian Technologies. And I would try as much as I can to explain a bit of what you see here. So traditional sites have always had what we call a remote management system, an RMS system. It's right here connected to a rectifier and battery cabinet. What a telco provider and a towerco provider tries to do is basically aggregate data from all of the sources, everything that is on site. So a site has a camera for access control. A site has a motion sensor. It has a gate sensor. It has a temperature sensor to basically say when things are about to blow up or when there's no cooling and there's potential heat. It has a smoke alarm when there's fire. It also has some kind of ATS cabinet. This ATS cabinet is what switches from generator to grid, right? And you have what we call current transformers that are wrapped around these cables to basically pick up consumption data and then basically extrapolate it and give you power. It probably picks current and then gives you power. Now, as part of this, you also have diesel, a diesel generator. It has an interface. That interface needs to be automated. There's a panel there. It can start, stop. It can also give you information on what is happening in the generator. Depends on how automated or how advanced the interface of the generator is. You have a diesel tank, small, nothing standard. It goes from 1,000 liters to 5,000, 3,005. You need a probe, a fuel probe that is adapted for all of these scenarios, right? The lack of standardization of a lot of the devices in these sites creates an opportunity where you have to innovate just beyond the traditional. So you have to get a fuel sensor that can basically be a fuel probe that can be calibrated irrespective of the size of the tank. The cover also, you need a sensor to see when it's open, right? These are things that, and outside of all of this, traditionally these sites, a lot of these sensors were wired to the controller on site. The future of a lot of this is to have wireless sensors that are basically moving this, and some of them are hidden. The essence of this is to make it more discreet and vandal-proof. Once you have vandal-proof sensors that are hidden, it also allows you to collect more data without any interference from third parties, right? And the idea for certain is that to some point, a lot of these technologies will be doing short range RF, right? So when we look at it here, the green is for there's wireless Bluetooth, there's Wi-Fi, and there's short range, the LoRa, right? Not LoRaWAN. You have also RS-45. In a few cases, you probably have to run a cable. So when you see here, you see the rectifier is being connected with a cable to the RMS. So it's a short distance, that's fine. You see the diesel generator controller is connected with a cable to the controller that it interfaces with it, right? Now, at the end of the day, there is a limited amount of the connectivity that is wired. A lot of it is wired. So the essence of this is how do you aggregate power from all of these sites into an RMS? That RMS now has a MQTT connection, and then it shoots the 3G, 4G, NB-IoT, whatever it is, back to a management platform. That management platform is deployed by the towerco and also integrated into an enterprise hub, all the systems that they have in their NOC, or even if they have a data lake and they want to run AI, right? So that's the context here. Two things that come to play is there's need for IP. IP is high streaming and more of what we call low latency type of the IP camera video streaming needs some kind of low latency. So to that, you have to design the communications in such a way that you get this low latency. And even if you don't have that, you need the RMS to some extent to also do some edge compute. So that edge compute helps you aggregate data and move it back to the back end, right? So that's the architecture of a traditional telco as it stands. There is the part where you are integrating solar and then you're integrating more power sources, maybe wind, and you're putting solar, or you're looking for all sorts of different power sources. Now, once you have this RMS and you integrate more power sources, it transitions to what we call DERMS. Now, DERMS now has what we call a massive, so this is monitor, a bit of control, but DEMS now has sequencing, right? Because when you start putting a lot of power and you connect it to the grid, if you upgrade this remote management system to a distributed energy resource management system, then it can be able to sell power. So the future of the grid is you have power sources everywhere. So let's assume Nigeria has 40,000 power towers, and you can build a device that can be deployed at every 40,000, all these 40,000 locations, and you are able to take power from the grid, have battery management backup, and also, hopefully, the grid is able to also accept the power that you don't need. What you will then need is what we call a net meter. A net meter will now give you a net of what you are consuming versus what you're selling. So once you aggregate all those 40,000 locations together and you create an energy market, which is what it looks like is happening in a lot of places around the world, that energy market now gives you a net of your consumption versus what you are producing. So you become a pro-consumer, right? Or a prosumer, as they call it, right? So you can turn a towerco business into an energy business. And in some cases, you can elevate it to what we call virtual power plants because you virtualize the sale of the power, because you will get more battery banks, generate with solar, generate with wind or whatever you can, store, power the site, and still sell to the grid. So this is a power management framework that I think it's somewhere there can be a lot more innovation. That evolution can transform tower cos into virtual power plants. So credit again once to Circadian, who provided this kind of base architecture. And I'm open to ask to any types of questions that come up for this particular tower co management framework. So I'll go once more to a small architecture, solution architecture that just gives you, and I don't know if it's clear enough, but the whole framework I've provided, this is more like a solution architecture that takes a deep dive to show you the different engines that are aggregating. First, at the first level, the edge telemetry and compute, where you have AI interference, image storage, config engine, alarms engine, the database, OpenVPN client, an update engine. Then everything goes into interfacing an MQTT broker and then moves to a cloud platform where you now have front-end applications that are doing live monitoring, right? That application will now have some cloud API, and then you have a data lake for the enterprise client, so be it whatever kind of company that needs that data, they can use it to make business decisions, trend, look at consumption patterns, and make those decisions that evolve the business from one point to the other, right? Again, at the bottom, you see the type of sensors. There's there's a trend to use much more wireless sensors than use wired sensors. The wired sensors will be only for very short distances and areas where you basically have to just do RS-485 Modbus straight. Now, a lot of the other sensors for door sensors, all the smaller sensors are all short range wireless technologies. And then the backhaul from the RMS, the edge telemetry or compute unit, is obviously the one that's the IoT that I mentioned. Either it's LoRaWAN, is it Sigfox, is it RPMA, or is it the different variants of CAT 4G LTE CAT M1 or NB-IoT, right? As the case may be. So that's the summary of my presentation. I hope I have touched on the key areas. I don't know how much time I took, but I think I tried to make everything within 30 minutes so that we can have some time to go back and forth on discussions relating questions. Thank you very much.
Awesome. Thank you so much, Shehu, for that concise but power-packed delivery. Yes, so again, reminder to everybody, please put your questions in the Q&A, or you can use the chat. We'll take any questions at all, whether it has to do with power management or the innovation challenge as a whole. And so, Shehu, we've got two questions so far. The first one is from Usman, and he's asking, this is a more generic question. He's asking, what are the primary goals of power management in a smart grid?
So at the end of the day, a smart grid is a grid that has intelligence at every point, right? The old grid was designed to move power from areas where you generate, which is really hydro, to load centers. So in Nigeria, in 1965, they said, oh, let's build Kainji. So Kainji was in the middle of nowhere in Niger State, and it could do 900 megawatts. But nobody can use 900 megawatts in Niger State, right? The load centers were Lagos, and all this. So you need a grid. So you have to move all of the power to Lagos. And then also ensure that as you are moving the power, you're also serving the areas that are close by that are not major load centers. So that's why you build a grid. So now you have gas power plants in the south, and then gas pipelines that take power to power the power plants, and then also connected to the grid. So the essence of power management is for you to be able to, basically, power is sent from the generation, and then also money comes back from the consumer, right? So you send power, and then it's in two directions. The future of the grid is to have power also being sent by the consumer. So the essence of power management is to have all these points connected with different sensors so that you are looking at how the power is moving and also tracking how much of the money. So the meter is what collects your money, but the DCSs and the automatic generation control systems are what tracks your generation on the grid, right? The SCADA really is what tracks your generation on the grid, but your meter is what helps you get your money. So all of these things connected is where you have like an energy management system, a power management framework. Within the context of this presentation, I try to focus on only the part that is more consumer-centric, where you're looking at, okay, meters and what are the opportunities in metering all the way to the discos. I left out the grid company, TCN, and I left out the generation because that area is more enterprise grade and much more challenging for a startup to go into. If you fix the metering, then you can attempt to go into those areas. So that's the summary. Power management is critical because you need what we call liquidity. Liquidity is what is basically balancing your generation with the money you're collected. On the average, you shouldn't lose more than 10%. This is the standard, maybe 10, 11% of the electricity you're generating. But yeah, in Nigeria, in some places, we're losing 70% because of lack of power management and lack of proper monitoring. Thank you. I hope I answered the question right.
So Usman, hopefully you got the answer you needed. If not, feel free to pop in another question before we close.
Yeah.
We have another question. This time is from Pius, and I'll read out the question. So he said, you said something about collecting data from any meter. I am currently working on something similar, but the meters I am working on have an RS485 port for Modbus communication. My question is, do all meters have a communication port? Because if not, how then does one collect data from any meter?
So all the meters that are deployed for the purpose of this presentation, maybe I focus on Nigeria, but it's an IEC standard. I'm a member of AFSEC, right? The Africa sub-unit of the IEC measurement and control TC13. TC13 is the Technical Committee on Measurement and Control in the IEC. IEC is the standard body for electronic and mechanical standards. Now, AFSEC is a body that works across to make sure that there is standardization. A subset of that in Nigeria is the Standard Organization of Nigeria, and then you have NEMSA, National Electricity Management. So all meters are tested. They must meet that requirement. There must be an RS485 port. The challenge is the RS485 port is really just an interface. You have to be able to interpret the messages coming out of it. So all meters have that. There's also the problem where you cannot interfere with those meters when they are installed by a disco, but in a lab, there are meter test stations everywhere. These meters have to be tested in batches, and each one must come with that requirement, that port. It is a requirement, and if the port is there, there's usually a network interface card connected to it. So if you need to remove the network interface card and talk to the meter, that's a discussion you can have with the manufacturer of the meter or the disco that approves or buys it, right? So it is something that is standardized. So the RS485 ports are what are standards in the metering code. So we have also a metering code that is revised every maybe 5 years. I think it hasn't been revised since 2015, but it will be revised soon. Thank you.
Awesome. Thank you so much for that, Shehu. And so we have another question. I really love this question because it's asking about the application of skills to this area, right? And I encourage everybody to think in these terms. So this is a question from David, and he's saying, thanks so much for the insights, sir. What are key areas of innovation? What key areas of innovation can you suggest for security, especially with surrounding awareness, in bracket camera and motion detection? I would really want to know because I am enthusiastic about computer vision and its application in this case.
Okay, so part of what we know is that there is so the challenge that I see, first of all, is that a lot of, like I showed you telco sites for the last maybe 20 years, telcos have been collecting data of people that go to their site to steal, right? There is an opportunity to match the facial recognition or the pictures that are taken to a database. Whoever is able to build that and work with the authorities such that you can basically take data of somebody in a site and match it to a massive, so you need a data lake, right? That data lake might be sitting with NIMC, the National Identity Management System, and then, or even maybe the banks, right? So you're able to take that information from a camera and match it. So a lot of times, a lot of telcos have deployed it. Now, the question again is just beyond that technology where you provide or you are able to design a solution that helps to provide this kind of intelligence, you are also required to also, the call to action is really the problem. So even if you have a facial security solution that helps you map somebody on site to his database, his information, there's also the fact that you need the police to be able to go make the arrest and charge the person to court with that information, or do the investigation and also make sure that there is consequence for that theft, right? So when these systems are not in place, it makes the technology just like, okay, we have technology, but what is it for, right? So I think that's an opportunity. On cybersecurity, obviously, there's tons of opportunity there as well. The token generation that is being done by meters now, where we have to take a token and press it on the meter, it's also an issue that was evolved out of the fact that they wanted to do security in hardware. So that token generation is done by hardware that sits in the disco. Can't we virtualize that? Is it possible that we can virtualize and let the token just move once you have money, and then the money generates the token and it moves to the meter and you're not taking numbers all over the place? These are opportunities that are available, and I think innovation can help us drive just beyond the point where you're taking, most of African countries, they use STS technology. It's a technology that was developed by ESCOM, people in ESCOM and in South Africa, because they did not want to be sending meter readers to people's houses, right? And it's been adopted worldwide. But now that there is communication, maybe that technology is obsolete and we need to have something that makes it a bit more easy and more tech-friendly. So I hope I answered your question.
Yeah, I mean, it sounds to me like you did. David, if you have a further question on that, please share in the chat. And so we have another question. This one is more about the competition generally, so I can take this one. Question is from an anonymous attendee, and he's asking, or they're asking, what's the scope of the hackathon? Can simulated devices and simulated data, including simulated sensors, be used in lieu of real device and real-time data or physical devices? And so the short answer to that is yes, please. The design is obviously a huge part of it. And if you're able to design something that is feasible and you can simulate that and the judges are impressed by it, then you definitely stand a chance. Of course, I guess this is just a pro tip from me. The more you are in the design realm, obviously, the higher the standards that will be placed on what you're submitting, right? Because it has to be really great design. But again, the emphasis of this challenge is we want to encourage that all-round, all-round thinking. Whatever it is that is your expertise, bring it to bear, and you stand a chance of winning. The main thing we're looking at is, how like, again, I like using this word crazy, right? How crazy is the idea? Are you really pushing the boundaries in the way you're thinking and the way you're implementing it? So the short answer to your question, anonymous attendee, is yes. Simulated designs and the likes are definitely allowed in the submission. So there's one other question from David as well. And David wants to know if you have any insights into what policies are in place to ensure privacy protection.
Okay, so if I speak on power management and metering, I think there is a document by NITDA that all CIOs have to sign. So there is an identity information compliant regulation that everybody has to sign. So I just need to find the name. Even CIOs in banks, CIOs in MT telcos, CIOs in utilities have to sign that. So once you sign that, the CIOs are mandated to, they need to share information. There is a level to which they can distribute consumer data. So I hope that answers my question, but there's a NIDA regulation. NITRA is the body that provides that regulation and has been doing that over the last couple of years.
Awesome. And we'll try and lay our hands on that document and share it in the Telegram group or, through where the DevPost site. And I'm sure, even though NIDA is Nigeria specific, I'm sure like the key tenets of the document will apply, at least
Globally, yes. There's also, and there's the European one also. Everybody just basically went on, and there was this identity management. A few years ago, every country just adapted it, and Europe were very hard on a lot of the consumers of online platforms, right? So, or rather, the sellers of online platforms that had a lot of consumer data. Yeah.
Cool. So we have a question from Kenechukwu, and he's asking if my startup or prototype is extremely good, but due to even higher, better competition, I didn't get top 3. Is it possible to get investor funding? That's a great question, Kenechukwu. And the short answer, I mean, anything is possible. So yes. Again, the idea of this competition is we want to showcase the best of the best, right? And while we are only giving cash grants to, and for now, who knows, as depending on how things look going forward, we may even increase the cash grants or the people who are giving cash grants to. That's still a possibility. But while we're only giving cash grants to the top 3 as well as the winner of the power management prize, if the pledge we're making to anybody who submits for this challenge is that if your submission meets the quality bar, whether you win or not, we're going to promote you and do our best to support you by connecting you with people who can help or potential investors and so on. So, it's still possible that you get whatever funding you need. Just put in the best submission you can, and we will do our best to make sure that you get the visibility and the connections that you need. So I hope, Kenechukwu, that answers your question at least a little bit. Great. So we have another question from Pius. And he's asking, how does one get access to IEE standards on metering?
So it's IEC, not IEE. So IEC standards. So you can go to the regulator's website. I think you go to the standard is in the metering code. The metering code references IEC, and then you can also go to IEC website to get that. But yeah, the metering code is on the regulator's website. In the case of Nigeria, the Nigeria Electricity Regulatory Council, NERC, and then also NEMSA, Nigeria Electricity Management Services Agency. And yeah, so if you just search metering code version 2 or something, you'll see it, right? And also IEC, the standard. So the metering code will reference the IEC. You go to IEC, you pull it up, you get it. Some of the information for IEC are not public, but some of it is also public. So these are open for Africa-wide. It's really the same IEC standards that are adopted by different countries, and the metering standards are relatively all the same, right? So that's the answer to that. Thank you.
Awesome. So those are the questions we've gotten for now. And if there are no other questions, then I guess we'll start wrapping up. I'll say a few things. If a question pops up before I finish, then we'll take it. If not, then we'll close after that. But just again, wanted to thank you so much, Shehu, for spending time with us. What the information you shared with us is invaluable. I've learned a lot personally myself. And I'm sure that everybody who attended live and who will be watching the recording um, also learned a lot. Again, folks, like this is one of the information sessions that we'll be holding, and there'll be more coming over time on different subject areas. So if you keep, follow us on social media, in the Telegram channel, your DevPost account, we'll be sharing more information about these sessions as they come up. I see we have two more questions. One is from Israel, and Israel is asking, Sir, you mentioned the NIC in bracket network interface card. Does this act as a standalone communication integrator interfacing with an external microcontroller card? Additional,
Yeah, can you hear me?
yes,
Hello? Okay, okay. So you were asking that the NIC card is standalone. In the future, more of what is happening is that card is supposed to be field replaceable, right? In some designs of meters, it is integrated into the board, which probably makes it cheaper. But for the purpose of future-proofing communications technology, uh, the recent designs are that card is hot pluggable, and it can be replaced after 10 or 15 years, or if the technology becomes obsolete, right? So there's a sense also, the UK set up a body that does smart metering communication called the Smart DCC, and they deploy 3G technology. And then the mobile network operators now say, no, 3G technology is a useless technology. We're no more doing it. And they had to spend $3 billion to replace the 3G cards in the meters, right? So these are some of the things that you have to consider. You have to future-proof a technology for 10, 15 years when designing your network interface card. And my recommendation and the recommendations of more of the recent designs for smart meters is that the device is hot pluggable and it is external to the main meter.
great. Israel, I hope that answers your question. If not, please, ask for clarification. And there's another question from an anonymous attendee who is asking, are citizens of the eligible countries who are currently living abroad also allowed to participate in the hackathon? And the answer to that is no. So for you to be eligible to participate in the hackathon, you have to be resident in the region, in Africa, in the eligible country. Please review the rules on the DevPost website for more details. Um, there's a question from David, and he's asking, is a team or individual allowed to make more than one submission for the challenge? Yes. If you feel that increases your chances, feel free to make, and you have a lot of bright ideas that you want to share, you can make more than one submission. Obviously, you understand the trade-off of that. Some people may decide to do one really, really, really awesome, high-quality submission, or spread it out to increase their chances. So, short answer is yes. And another question from an anonymous attendee is, can the solution for this hackathon track be categorized as an IoT smart metering solution? So I don't know if I understand the question, but I'll answer it the way I understand it, and you tell me if that helps. So I'll say, maybe I'll put it in the reverse, that an IoT smart metering solution can be categorized for the power management, right? Like if
Yes.
you build an IoT smart metering solution, you do stand a chance of and Shehu, please keep me honest. You you do stand a chance of winning the power management track, but it goes beyond IoT smart metering. Like you had mentioned, somebody is looking at something around computer vision. It could be anything at all that plays in the space of the architecture, and even maybe beyond that, there could be things that we are not thinking about. Again, remember, this challenge is for us to get like ideas and innovation from far out. So there could be things that were represented in the architecture that she'll share with us, or even beyond that, right? The whole idea of this session is just to spark that inspiration and get you thinking in that space. But yeah, so IoT smart metering is definitely aligned with this category, but there's way more beyond that. I don't know, Shehu, I don't know if there are some other ideas.
No, no, I mean, at the end of the day, yes, IoT itself is broad because IoT is device, communication, and then also application, right? These three things are very broad in itself. So power management is just the concept of, okay, how do you measure the electrons that are moving for power, whether it's from a generator, whether it's from a solar panel, all of these things. And at the end of the day, what are the technologies that allow the power management as a subset of deep tech advance, right? So the smart grid is what we have. The future is what we call the neural grid, right? There's technologies now that you see power substations are like data centers. There's only fiber optic cable going there and then the electric wire coming out. There's nothing there's no single button. Everything is concealed. And I've seen it myself. So this is the future of the grid. You look at the neural grid, you look at what other advancement is there. Is it AI, whatever it is, demand response? There's a lot of things. The pattern and behavior of people in consuming electricity. So it's broader than IoT. IoT itself is broad, but power management and the compute required to run the future grid, which is distributed. It's going to have intelligence at every point, right? It's not the traditional grid now that has a control center in the middle of nowhere, right? This one is going to be intelligent from the consumer, from the producer, everywhere. So that's the essence of the subset. So IoT, perfect, but there's much more, right? Yeah.
Awesome. All right. So just a note that we'll be wrapping up soon in the next 5 minutes or so. So if you have any last question, this is the time to ask it. We have one question from Israel, and Israel is going into the nitty-gritty now. So he's asking, sir, I understand your point, but wouldn't using two microcontrollers, one as a host and one as a slave, increase the cost? Most meter manufacturers are currently focused on minimizing production costs. Wouldn't it be more cost effective and efficient to integrate the NIC directly into the meter as an inbuilt module rather than as a separate unit?
I mean, I agree with you, and these are considerations that I've looked at recently. Recently, I was part of a forum trying to design a very cheap meter at $20. So please go for it. If you think integrating the NIC cards gives you an advantage and you can scale and your adoption is better, the question is, what is the adoption? If the adoption is better, then we are good with it. So go with your low-cost product, ensure that it is adopted by the market, and it will set the standard for the future. So I'm with you on that. The price point of a meter is really a problem. If you think you integrate the NIC card into it is better, yeah, I think a lot of people do that, and you share controllers and you share resources. It makes a lot of sense. I agree with you, Israel. So, but then look at the standards. You need to get those meters approved by the regulatory bodies, and they need to see that you are not deviating. The standard is a guide. You can deviate within it, right? So you can play around, but it's like a programming language. You can write your language anyway, but I think I get your point. If you are working to get cheap cost, you go with that. And if you can get a meter that is less than $10, and it works, we're good with that.
Awesome. So you heard it, break the boundaries, go for it. And that's really the spirit of what this challenge is all about. All right. So we don't have any more questions, and I think we're at time. And so we try to keep these within like 1 hour, just to be respectful of everybody's time. There's going to be, the recording is going to be shared, but please keep the questions coming even offline in the Telegram channel. We know where to find Shehu if we need him. And we can always pass the questions to him and get any responses.
Yeah,
Um,
I'm open. Thank you very much.
yeah, so okay, so there's a question from Joseph, and Joseph, I'll answer this one, but we can take further questions in the Telegram channel. But you're asking, are there any restrictions on the hardware we can use? Can our solution rely on intermittent internet access, or should it work fully offline? Is there a preferred platform for submitting our demo? So, no restrictions in this challenge in terms of hardware or whatever you're using. Again, it's all about innovation. We want to see what you're bringing. Can your solution rely on intermittent? Again, it's all on you. Obviously, take the environment you're building for into consideration. If you're building for Africa, right, then, if I was building for Africa, let me put it that way, I would design, intermittent internet access or fully offline, or, I'll design that into my solution, but it's up to you and what you're designing. But all of them are allowed, right? And then, is there a preferred platform for submitting our demo? Thank you, Fumi, for popping the link in the chat. You should register on DevPost. That's the hackathon platform that we're using to manage and accept submissions for this hackathon. There's a link there that from which you can navigate to DevPost and register, and that's where you submit. That's where you submit the application. And please read all the rules. Make sure that you're complying with everything we require for the submission, so that the judges have what they need to make the best decision possible. And yes, there's a channel. Joseph is asking, do we have a dedicated room or channel for people to ask more questions throughout the challenge? Yes, it's been open for about 2 weeks now, and it was just popped in the chat. And the conversation can continue there. We encourage these questions. We want these questions, so please keep them coming in the channel. Same goes to anybody who may be watching the recording of this. Okay. Once again, I know I've said it a few times, Shehu, thank you, but you can never say thank you too many times. Really appreciate you and your time. This has been an awesome session. I've learned a lot. And the questions as well, to those who attended, like, thank you for asking those great questions. When you ask great questions like that, you're not just asking it for yourself, you're also enriching everybody else who is watching. So, any last words, Shehu, before we close?
Yeah, no, not an excellent engagement. I appreciate all the thinking, Israel, Joseph, and everybody. Interesting questions, and I'm open. Please, you can reach me on LinkedIn if you have any questions, and also, Emeka, if anything, I'm open. Yeah, any more questions, I'm open to support and answer. This is an area we need to work towards. The problem of Africa is energy. Power is a big problem. Countries are propelled by the amount of energy they can consume and use to make productive work, right? So managing power is how, if you can manage power, you can increase the amount of power you are consuming and how much cheaper you can also sell it, and how well you can make it available to everyone. So I'm very passionate about things in the power sector. So please reach out to me anywhere, anytime, and I will be willing to answer. Thank you.
Awesome.
Thank you, Emeka. Yeah.
Awesome. Thank you so much. Thank you, everyone. And yeah, we're looking forward to those awesome submissions. And please keep the questions coming. Let's carry the conversation over to Telegram. But thanks so much, and see you on the next one.
Thanks. Bye.